Here we go, Module 3, Lesson 3. This one also has the Newton's 3 laws, primarily Law 2, force equals mass times acceleration, and Law 3, for every action, there is an equal and opposite reaction. So we're going to start here with Mary Poppins and an umbrella. It doesn't have a lot of information there, but we're talking about Mary Poppins as the little square. Gravity is pulling her down and air resistance is pulling her up, and she has that umbrella. It does not say air resistance is negligible. So we have 3 specific conditions, and you can try on your own to see which one of the answer bank works with each condition. So let's go check out what you did. Constant velocity, that is the important thing here. That means acceleration is 0. Force equals mass times acceleration, which means our force is 0. So this would be our force in the y direction is 0. What are our forces in the y direction? We have the force of gravity going down, so it's a negative, and a force of air resistance going up, so that's positive. The force of air minus the force of gravity is 0. So if I rearrange those terms, I know the force of air equals the force of gravity. And in that case, then the force of gravity arrow would be equal and opposite the force of air resistance. So you can still be falling and going in the downward direction. So the motion is down, but the acceleration is 0. So there are no forces being applied there. The second one, increasing velocity. What does that mean? We are speeding up. That means we are accelerating. Which direction are we accelerating? We're still falling. So the acceleration is positive in the downward direction. So when we look at these ones, the motion is down, the acceleration is down, and we use F equals ma. So if the acceleration is down, my net force is also going to be down. I'm going to need to have a bigger force in the down direction, which means the force of gravity is going to have to be bigger because I'm speeding up as I'm going down. The force of gravity is pulling down harder than the force of air is pushing up. So the force of gravity, longer arrow, force of air, smaller arrow. If we are falling at decreasing velocity, okay, that means we are slowing down. What's that called? Deceleration, or acceleration is equal to negative in the downward direction. We're still going down, but we're slowing down. That gets us that weird rule. Okay, the negative acceleration in downward direction is equal to the positive acceleration in the upward direction. That's the weird rule. Let's draw it again. So hopefully it clicks into place. Okay, so if I am slowing down, that means I'm covering less ground as I drop. Less ground as I drop. Okay. So in the downward motion area, my acceleration is negative. I'm covering less ground. I need to find where the positive acceleration is. So let's look at this picture in reverse. When I look at the picture going up, we cover small distances and then larger and larger distances. If you start covering larger and larger distances, you're accelerating. So our acceleration in the positive is up. That means our force is in the positive in the upward direction. So that means our upward pointing force has to be larger. Okay, so lots of little steps to point that out. Hopefully it's sinking in now. Our acceleration is in the upward direction, so our force is in the upward direction. So our force of air is going to be larger than our force of gravity. So even though our motion is going down, our acceleration is going up, which means our forces are going up. So you got to figure which one is pushing more. The air resistance is actually pushing more. Eventually, it could overtake it and it starts speeding and going instead of falling down, floating up. There are other relationships in the quiz. You may not get one of these. Read each carefully, find the positive acceleration for that answer. So Newton's second law is the reason that we could work through this. And the units for force are newtons. So let's break that down. That's because force is mass times acceleration. Mass is kilograms, acceleration is kilograms meters per second squared. So when we break this down, you could have the units kilograms meters per second, force, but that was so long to write that Newton, since he came up with the three laws and a bunch of other stuff, honestly, he was given that unit designation. So anytime you see kilograms meters per second squared, that is a force. Okay? And it's a mass times the acceleration. The best way to do these problems, same as before, draw your free body diagram. In the quiz, most of the time it's going to say magnitude, but honestly, even if it's not saying magnitude, it seems like all these quizzes are going to be focused on magnitude. So you want the absolute value of your force, your velocity, your acceleration, or your displacement. So Newton's third law, we've gone over that, but now we're going to give you the mathematical term. So here's the mathematical equation, and what that means, the force of object A on object B is equal and opposite to the force of object B on object A. So that's how you'd read off that sentence there. These are force pairs. There are only two forces, or two objects, force object A, object B. Object B, object A. There is no object C. So when you are doing the problem, do not give me an object C. There are only two objects in pairs because you could only have two of them. So what people like to do is they like to use the transitive property, which is not right. So I'm just going to say it a bunch of times. So if you have a table on Earth, then the opposite force is not the Earth on the cup. That is just that transitive property. If we talk about table and Earth, then the opposite force also has to talk about table on Earth. So what do I mean? So I'm using this picture up there at the top. And the one force is called the force from the table on the ground. Force from the table on the ground. And what is that going to be opposite to? Negative force of the ground on the table. How do we know this? What is the force of the table on the ground? That's the force of gravity. What is the upward force of the ground on the table? The force of the normal. So we've been doing this whole time, right? If it's not floating or being pulled down through the surface, the force of gravity is equal to and opposite to the force of normal. Your arrows are in opposite directions and they're the same length. Same exact thing, except for now we're just adding another way to describe it. Notice, if I talk about the force of the table on the ground, I'm not going to talk about the coffee cup, I'm not going to talk about the spoon or the phone, only talk about the table and the ground. So it could also give you another one, the downward force of the cup on the table. That's still the weight of the cup on the table. The upward force has to be the table on the cup, which is the force of normal. So even though the force of gravity in this first example does not equal the force of gravity in the second one, the downward force for both of them is the force of gravity. All right, let's get to some math. A 5 Newton force is applied. So we know this is force applied to a 1.92 kilogram object. That's its mass. To accelerate it rightwards. Acceleration is going to be to the right. Acceleration is not equal to 0, which means we are going to have a net force in the x direction. How do I know it's x? Because we're accelerating rightward. Left and right would be that x direction. The object encounters a 3 Newton force of friction. So that's the force of friction. Determine the acceleration. Some of these word problems are going to just have a lot of numbers in it for you to identify. Some of them are going to be thick with extra words. Just read slowly, identify. The givens you circle and write down what they are. The unknowns you underline. Okay, and then draw your free body diagram. Now, again, I'm always going to put the 4 standard forces up, but you could just draw it from scratch. That is fine. And then label it. Instead of force applied, what do I know that is? That's 5 newtons. Instead of the force of gravity, I don't see force of gravity in any of my labels, but what do I know? The force of gravity is equal to the mass times the gravity. I have the mass and I know the gravity because it doesn't say we're on a different planet. So I'll use Earth's gravity. 1.92 kilograms times 9.8 meters per second. Okay. Force of normal. Go back and read it. It's accelerating rightwards. Does it say anything about up and down? No. So the sum of the forces in the y for this problem are going to be 0, which means my force of gravity is equal to my force of normal because there is no acceleration in that direction. So there's no net force. They have to be balanced forces. What else do I know? Force of friction is 3 newtons. Okay, so I'm gathering a lot of details here. What else? Sometimes you get here and then you're like, okay, I wrote everything in. What else am I going to help with? Notice my force in my x is mass times acceleration. My force in my x is 2 newtons. How did I get that? Because I can subtract these two and then the arrow goes in the direction of the bigger force. Okay, so I had, I had 1, 2, 3 newtons pushing to the left and 1, 2, 3, 4, 5. So 3 on both sides get canceled out. I'm left with 2 newtons pushing to the right. That is my net force in the x direction. Hey, I know that equals mass times acceleration. Now I'm getting there. I'm going to be able to fill in some more terms. Okay. So my force is 2 newtons. My mass is 1.92 kilograms. And guess what? I got one unknown left. So I can solve for the acceleration. And that would give me my answer for that problem. Right? So, let me just do it right here so that you have it. 2 divided by 1.92. It's going to give my acceleration as 1.04. Remember, if it says round to the hundredths, round to 2 decimal places. So 1.04 meters per second squared. All right, next guy. Canada is going for the win in curling. Their 17 kilogram stone mass is decelerating. So acceleration is negative, which means we do have a mass times acceleration in the x direction. Curling is a sport on ice where you push the stone, which is like a little heavy, kind of cylindrical object. It's hard to describe. And they try to get to a target. So I know I'm going to need to use that mass times acceleration in the x. Okay, the stone decelerates from 100 feet per second to rest. Both of those are what? They're both velocities. From, so this is velocity initial, to, so the rest is velocity final, which means 0 meters per second, in 25.1 seconds. Assuming air resistance is negligible, so the force of air resistance is 0, so we don't have to worry about that. Determine the coefficient of friction, okay, between the stone and the ice. So as always, we go ahead and we identified our givens. Our unknown is the coefficient of friction. Remember, that's that weird mu-shaped object, okay? And now let's label our drawing. So what do I know? Okay, it's not the moment where we've pushed the stone, okay? So I don't have a force applied. I do have a force of gravity. And that is 17 times 9.8. It's going along the ice, so it's not accelerating in the up or down direction. So the force of gravity equals the force of normal. Is that balanced out that way? What else do I have? No force applied. Oh, but I do have friction. It says negligible air resistance, but does not say negligible friction, especially since it wants us to determine the coefficient of friction. So that force of friction is definitely going to be something we need to solve for. So what other information do I have? The y direction is not super helpful right now, but in the x direction, I know the force of friction is going to equal mass times acceleration. How do I know that? Because the forces in the x have to equal mass times acceleration. I just only have one force right now. So I have that. Do I have a mass? I do have a mass, 17 kilograms. Do I have an acceleration? I do not. So I can't find the force of friction yet, and I can't find the acceleration yet. So I need some other way to either find the force of friction or find the acceleration. What other information is in my problem? Oh, I didn't touch this initial velocity or the time. Is there equations that's going to help me find acceleration given the velocities? Yes. But before I go on and even look for those things, what is this? Feet per second. What is it supposed to be? Meters per second. I need to change that before I forget about it. So I'm going to convert my feet per second into meters per second. So I'm going to put a little X here. Now put velocity initial down here so that I don't even accidentally put it in the problem. So I have a velocity initial, I have a velocity final, and I have a time. And I'm trying to find the coefficient of friction. So let me get started. What equations with coefficient of friction? Notice you don't have to say U equals something. It can just be in the equation. So I want to solve for that. So I need the force of friction and the normal force. Do I have the normal force? I do have the normal force, 17 times 9.8. I don't have the force of friction. But as I was talking about before, if I have the acceleration, I can find the force of friction. So what is my velocity equation that I can use? V final equals V initial plus AT. My V initial is 30.48. My velocity final is at rest, so it's 0. I don't know my acceleration. My time is 25.1 seconds. So I can solve right now, and I can get an acceleration of 1.21. Where can I put that back in? Go and look at what other equations you have. Can I put my acceleration into the force of friction equation? I cannot yet. What other equation has force of friction? This guy over here. The force of friction equals mass times acceleration. So now I can put the mass times the acceleration in and get the force in the X. Now I have the force in the X. Yay! So when I look, that would go in this missing spot. And now I can finally solve for my coefficient of friction and get 0.12. So in this one, you needed, yes, 4 different equations to get the answer. We are stepping up our game, multiple steps. That's why it was important to have that good foundational skill right there. And again, you can watch this one a couple of times. Watch it once, take notes, watch it again where you try it on your own to see if you can get those ones. That is the best way to learn these math ones, is just repeat, repeat, repeat. Okay, so I have a 2 kilogram surveying weight, which is called a plumb bob, that's its mass, suspended by a rope and is accelerated upwards. So my acceleration is going to be positive in the up direction from an initial rest position. So velocity initial equals 0. If the tension in the rope is 5 newtons, so that's the force of tension, then determine the speed of the plumb bob. Okay, so velocity final, because we have velocity initial here, after 3 seconds. The after also tells us we need that velocity final. So again, I'm going to look at that equation. Velocity final goes velocity initial plus AT. My velocity initial is 0. Do I have an acceleration? I know there's 1, but I don't have it yet. And a time, 0.3. So to find the velocity final, I do need to find the acceleration. Okay. I circled and identified my givens. I underlined my unknown. What didn't I do? Draw the picture. Draw the picture. It will help you out. What do I know from this? The force of gravity is 2 times 9.8, because the force of gravity is equal to the mass times gravity. That is the weight of the object. What else do I know? There is no force of friction because there's nothing going left or right. It is just something on a screen. Force applied. We don't have one of those. Do we have a normal force? We don't have a normal force. Why not? It's not resting on something. What is this though? This is going to be the force of the tension, because this is the rope that is holding it. So the rope is giving it some tension. So even though we don't have the standard 4 forces, we still do have a force of tension acting up and a force of gravity acting down. So my sum of the forces in the X this time are going to be equal to 0 because there is nothing there. Okay, so 0 minus 0 is 0, but my sum of my forces in the y are now going to be a number. Why? Because we know we're accelerating upwards. So the sum of the forces in the y direction is going to be equal to the mass times the acceleration. Okay, so what does that tell me? And you could also call that the force applied as opposed to the force of normal or the force of tension. Okay, and that was given to us as 5 newtons. What else do we know? Okay, and that's writing out all those equations we already written down before. There we go. Force of net. The sum of the forces is going to be equal to the force of tension minus the force of gravity. Okay, the force of tension is going up, so it's positive. The force of gravity is going down, so it is negative. The sum of the forces, force of tension minus force of gravity. That is not going to equal 0. It's going to equal mass times acceleration. So what does that tell us? The force of tension is 5. The force of gravity is 2 times 9.8. So 2 times 9.8 is 19.6. So 5 minus 19.6 is going to give us negative 14.6 newtons. That is because of the direction that we are going. Okay, what's next? We need to factor in my mass and my acceleration. So negative 14.96 is equal to mass times acceleration. Negative 14.6 is equal to, what's our mass? 2 times acceleration. So my acceleration is 7.3 meters per second squared. Okay, and you're going to change that to the magnitude of the positive number. In real life, yes, you would have kept that negative and you would have said, nope, it's not actually accelerating upwards, it's accelerating downwards. But for this lesson, at least, they are just wanting that absolute value. So your acceleration is 7.3. And you can put that back into that original problem to find our velocity final is 3 meters per second. And then on the next video, we'll do some higher level questions. And let's see if we can turn off the recording.